Okay, today we're going to talk about collinearity, betweenness, the triangle inequality theorem, and some assumptions we can make when we're talking about our diagrams. The very first thing we're going to talk about is some definitions here. With collinear, we're talking about points that are on the same line. So if I was to have a diagram of these 3 points, clearly I can see that A, B, and C are existing on the same line. Non-collinear would be an example of points that are not on the same line. So if I was given 3 points, say D, E, and F, they do not exist on the same line. And betweenness is a case where you have a point that is between 2 points, but only if collinear, which in our case we could say that E is between because it is on the same line as A and C and between A and C. We have 2 cases that will help distinguish between being between and not. So if we were to have 2 segments joined together to form the last segment, when we said that this segment was 6 and 5, then in order for R to be between K and W, it would have to lie on the same line as K and W, but also that would mean that segment KR plus the segment RW would have to equal segment KW. In order for that to not be true, when you have 2 segments that come together and say this is 8 and 3, and we'll call this points R, S, and P. Clearly, R and P is not 11, but let's just say that it is 10. Then segment RS plus segment ST would not be equal to segment RT. Some examples that will help. We'll look at the next diagram here. So if we were to first ask, what are the angles with the vertex of M? M is our vertex up here. We have 3 separate angles that we were talking about. And we can have this small angle right here, small angle up here, or the entire combination of the angle. And there are many different ways to name the angle, but there are 3 different angles. We could first name this small angle right here, which would be angle AMP. We could also name it AMP or reverse the angles with the letters around. We could then also use a number to name the other strong angle, angle 1, or use the letters of HMP, or reverse the letters, or include T. Then if we were looking at the combination letter, the combination angle, using the entire one, we go angle AMH. Again, reversing the letters or the other letters on the rays, but the key is that M, being the vertex, must be in the middle. We're talking about collinear when we are looking at collinear between H and C. So we're talking about points that are on the same line as H and C. The points that are on the same line as H and C would be M and N. Looking at number 3, relates to number 2, but in order to be between M and C, they must lie on the same line as M and C. First, and then be between them, which is H and M. Name the points between M and G. M and G don't connect, but they are collinear because I could draw a line to connect M and G. But in the diagram, I cannot notice any points. There's not clearly any points on the same line as M and G, so that is not possible. The next thing we're going to talk about is the triangle inequality theorem, which states that the sum of any 2 sides of a triangle must be greater than the third. When we're doing this, we're going to take the 2 small sides of the triangle that we are given and see if it is greater than the third. For example, we'll add 5 and 6. Is 11 greater than 7? Yes, therefore it is a triangle. For number 2, we will add the sides 1 and 2, and 3 is not greater than 2, therefore it is not a triangle. For number 3, we'll add the sides 2 and 5, and 7 is not greater than 8, therefore it is not a triangle. And for the last one, adding the 2 small sides, we're doing 5, and since 8 is greater than 7, then yes, it is a triangle. And moving on to the last thing I want to talk about. It's really important that we understand some different things that we can assume and not assume when we are talking about diagrams. One of the biggest things that we have to make sure that we do not assume is measurements of angles. It is very clear in this diagram that this angle is a right angle because it states that it's a right angle. While it may look like angle ABC is a right angle, we cannot say that it looks like a right angle, that it is a right angle. So we cannot assume the right angles or any measure of angles. It's also something that we cannot assume that's related to that, but we cannot make assumptions based on congruency of segments or angles. In order for segments or angles to be congruent, they need to be marked congruent. Given measures, they have to give us some sort of information. Another thing that we can not assume in a diagram is the relative size of segments or angles. There are some things that we can assume when we are looking at diagrams. We can assume that we have straight lines and angles. So I can say that an angle DEB would be a straight angle. I can also assume the collinearity and betweenness of points based off of our definitions before, whether or not they lie on the same line. As long as it fits those definitions, then we can assume the collinearity and betweenness of points. And the last thing that we can assume is the position of points. I can say that E is to the right of D. We'll talk more about these as they come up and as they relate to proofs, but these are some key things that we have to make sure that we assume and do not assume when we're looking at our diagrams. And that concludes today's lesson.